You are probably familiar with the SR-71 Blackbird, the symbol of America's strategic reconnaissance. In over 25 years of service, the SR-71 evaded more than 4,000 anti-aircraft missiles without ever being shot down. This confirmed its position as one of the most powerful reconnaissance aircraft in history. But despite its superior performance, the SR-71 had two major weaknesses. First, a high accident rate. Of the 32 SR-71s built, 12 were lost to accidents, usually during test flights or training rather than combat. Second, huge costs. Each SR-71 cost around $34 to $35 million in the 1960s, equivalent to more than $250 million today. The total program cost several $billion from 1962 to 1998. Each flight hour cost $200,000 to $250,000 in 1990s values. Complicated logistics gradually became less effective and officially retired in 1998. Although Lockheed Martin has not stopped giving up its ambition to develop a new precision supersonic aircraft. By 2022, they stirred curiosity with a promotional campaign involving the Maverick token, a social media post hinting at the need for speed SR-71 legacy. With the concept developed by Skangworld rapidly evolving on screen at the same time, a short video introducing the designer, Dream Studio Canworld, who said, "I am Dream. I work at Canworld, where we imagine the future." Welcome to Global New Military Updates. This is where military developments, global strategy, and modern weapons power are updated with a deep and emotional personal perspective. Each video is a beat of the times, where we analyze and reflect on power, war, and peace in a turbulent world. Ladies and gentlemen, don't take your eyes off the screen, and don't forget to subscribe to the channel, as well as leave a comment below. Mavericks, the supersonic plane soaring through the sky at Mach 10 speed, making the audience amazed. At first glance, Darkstar seems to be just a product of Hollywood imagination. But clues from Lockheed Martin make us wonder, is Darkstar the shadow of SR-72, the secret hypersonic aircraft project being nurtured? Nicknamed the son of Blackbird, SR-72 is not only the successor to the legendary SR-71, but also a statement of America in the global hypersonic arms race. So what makes the SR-72 so terrifying? And why are rivals like Russia and China rushing to catch up? Such as special refueling, GB-7 in the air with KC aircraft, AB-A5Q further increased the cost. With the development of reconnaissance satellites, SR-71, although not directly mentioning SR-72, these hints have made many people think of the Project Secret, that the company has been public since 2013. The clue, VSR-72, appeared more clearly than before in 1/2018. Draco Banner has the president in charge of advanced development projects at Lockheed Martin. Speaking at the SIDEX Forum, organized by the American Institute of Aeronautics and Astronautics, AIAA, in Florida, he showed an illustration of SRD-72 and discussed it as a remarkable technical achievement. Mr. Bannon shared without digital transformation, the plane you see, Kia, could not be built 5 years ago. We could not make this engine. It would melt into dust. But now, thanks to B&D printing technology, we integrate the system. Cool, complex, right in the engine. Material helps it withstand multiple launches and operate normally. When Bloomberg asks more in September 2017, Aviation Week reports the discovery of a mysterious drone, possibly a small-scale prototype of Astro-72 technology, flying near the U.S. Air Force Plant 42 in Palmdale, California, where Scoundrel is based. After this information was published, Aviation Week contacted or Orlando Kavanaugh, VP of Aviation Operations at Lowe's Martin. He replied, "Although I cannot disclose details, let's just say that Skynet Team 5 at Palmdown is putting all their efforts into speed commitment." This vague assertion does not deny, but rather increases speculation that Lowe's Kim Martin is working on developing SR-72-14. October 2022, Lowe's Martin posted on X, "Part of the dot store model used in the Top Gun Maverick has been on display at the AFP Air Show at a weekend event. This is a movie model, not a real plane." However, the appearance of this model, together with the collaboration between Lowe's Martin and the film crew, makes people believe Dot Store is a reflection of the SR-72 concept. In terms of design, Darth Vader in the film has many similarities with SR-71. Long fuselage, pointed nose and lower intake configuration, reminiscent of the Blackbird features. However, SR-72 is designed as a drone different from Darth Vader with a pilot in the film. The term hypersonic indicates speeds exceeding Mach 5, about 6,176 kilometers per hour, and Saudi Real 72 is flared as Martin aims for Mach 6+, far exceeding the SR-71's Mach 3.32 fuel. U.S. aviation technology now capable enough to make that store a reality. Let's explore its performance through the lens film and reality. Performance of Dostar fighter. In token, Dostar appears with a distinctive, pointed nose design optimized for aerodynamics, and the engine system integrated into the fuselage. When Captain Biz Marvel's Mito starts, he pushes the control stick to the maximum, activating the afterburner. The rear nozzles burst into a long flame, and on the runway at a military base, the plane skids a long way before takeoff. The airflow from the engine is so strong that it blows off the roof of a nearby guard post, causing Cho, a panicked employee, to dodge. As a test pilot controls by Storrell stated Cho with a large angle of bank, the plane still retains excess kinetic energy. Speed gradually reaches max BA.5, and when the flaps at the air inlets open, the airflow moves from the turbine to the engine. The supercharger force is called scramdress, is one of the rare technologies that can reach supersonic speeds. This is a real concept. SR-72 uses TVCC system, combined turbine with speed low altitude, and scramjet, supersonic speed. When the supercharged jet engine starts working, Dostar quickly surpasses the Blackbird's 6th century and reaches max speed 7.1. At this speed, the front of the aircraft starts to redden due to the heat from the shockwave at supersonic speed. Finally, the design of Dove Store in the Top Gun Maverick is technically reasonable, although it is a structural product. When taking off, the aircraft needs a long glide on the runway. At this speed, the lift mainly comes not from the wings like conventional aircraft, but from the shockwave formed around the fuselage. This concept is similar to the Wave Rider design once tested by the US military, such as the X-43A. However, shockwave-based aircraft are often inefficient at low speeds, requiring a long runway to reach the necessary speed before takeoff. To meet this requirement, Rosco uses two engines, turbine engines for low speed and supercharged jet engines for supersonic speeds. Unlike conventional jet engines, Scandress does not use only mechanical compressors, but relies on supersonic airflow through the engine to compress and extract fuel. This gives the ability to maintain speed high, far beyond traditional systems. However, scramjets only operate effectively at supersonic speeds, i.e. Mach 5 and above, so are not suitable for takeoff or landing. So designs like Dastor or SR-72 actually have to incorporate turbine engines to support the initial stages. This technology is the foundation for projects like Lockheed Martin's SR-72. Although the actual maximum speed of SR-72 is expected to be around Mach 6, plus lower than Mach 10 in the movie, scramjet engines are one of the most advanced technologies in the field of supersonic, but it has its limits. Although it can reach Mach 10 under ideal conditions, the maintaining this speed on a reusable aircraft is still a big challenge to overcome. The Mach 6 to 10 limit, researchers are exploring the OGWE, slanted shockwave detonation engine. This is a new system using tilted shockwaves to compress the gas, then triggering an explosive combustion process. Instead of a steady burn, this process creates a supersonic detonation wave, providing a high thrust ratio, superior thermal efficiency, and fewer moving parts. However, ODWE is still in the research phase, theoretical and simulation testing not yet in practical application. In September 2011, the U.S. Defense Advanced Research Projects Agency, ARPA, and the U.S. Air Force successfully tested the concept of a hypersonic weapon, SAWC, with a scramjet engine developed by Northrop Grumman. The missile reached a max speed of 5+ and flew more than 300 nautical miles. That is 555.6 kilometers. By March 2022, Lockheed Martin conducted a Sawhawk test, reached altitudes of over 65,000 feet, that is about 19.8 kilometers, and max speed 5+. Although the specific flight distance was not made public, these were important steps, confirming the U.S.'s leading position in supersonic technology based on air intake engines. However, SAWC is a missile weapon, not a manned aircraft. Like a destroyer, in addition to the engine materials that make up the fuselage and pilot safety are two major challenges when designing a supersonic aircraft. At Mach speed 10, the phenomenon of aerodynamic heating due to air compression and friction causes the surface temperature of the aircraft to reach 2,000 to 3,000 degrees Celsius, far exceeding the endurance of conventional alloys, such as aluminum or steel. For example, the SR-71 at max BA reached temperatures of 300 to 500 degrees Celsius. Forced to use titanium at max 10, more advanced materials are needed. Composite carbon fiber is good at heat, about 1,500 degrees Celsius for a short time, but not enough for max 10. Aramid Cabla fiber can only withstand 400 to 500 degrees Celsius, mainly used for durability, not heat resistance. CMC foam technology is the most effective solution, withstands 2,000 to 3,000 degrees Celsius, has been applied on spacecraft such as SpaceX and X-37B, as well as the SR-72 project. However, using heat-resistant materials such as ceramic composites alone is not enough to protect supersonic aircraft at Mach 11 speeds. The bigger challenge is cooling the fuselage when surface temperatures can reach 2,000 to 3,000 degrees Celsius due to aerodynamic heating. To solve this problem, researchers have proposed using cooling liquids such as two-sour liquids circulating in the channels inside the fuselage. Liquid hydrogen with an extremely low temperature of -253 degrees Celsius not only absorbs heat effectively, but also vaporizes during cooling. The hydrogen can then be injected into the engine scudras, take advantage of its flammable properties to increase thrust. This method has been applied on experimental programs such as NASA's X-43A, where two liquids are both cooled and fueled. Thus, both heat-resistant materials and active cooling systems are important research directions for hypersonic aircraft and spacecraft. However, another problem more serious for hypersonic fighters is pilot safety. Currently, no country has come up with a perfect solution to ensure safety for pilots on hypersonic aircraft. With pilots, the problem is not in the high speed, but in the acceleration. G-force acting on the pilot's body when the aircraft flying changing speed or direction. Research shows normal pilots can withstand up to 9 Gs for a short time with anti-G suits. But with special training, some elite pilots can withstand 10 to 12 Gs for a few seconds. Lateral acceleration is particularly dangerous because it can disrupt blood circulation, causing lack of oxygen to the brain, or even rupture blood vessels if the threshold is exceeded. At Mach 10, even small maneuvers can create accelerations far beyond human capabilities, leading to the risk of serious injury or death. E.g., in the movie Iron Crew, controlling the dock store beyond Mach 10 and continuing to accelerate, a scenario of a loss of control signal may imply the physical limits that pilots face. To eliminate this risk, the most effective solution is to convert the super combat aircraft into a UAV version. This not only ensures safety, but also allows for a design focused on optimizing the current capacity. No need to worry about human physiological limits. Actually, SR-72 was developed as a UAV from the beginning with a target speed of Mach 6. Plus, global hypersonic race, China's WG-8 and Russia's MiC-41. The move to drones like SR-72 is not only a US trend, but also pursued by other powers. In the fierce hypersonic race, China with WG-8 has proven its capabilities. Publicly launched at the 2019 parade in Beijing, J-8 is a hypersonic UAV developed by Aviation Industry Corporation of China, designed for strategic reconnaissance. WG-8 operates at an altitude of 50,000 meters with an estimated speed of Mach BA to Mach 5. Does not take off on its own. It is launched from an H-6M bomber. Uses a rocket engine to achieve altitude and speed. Equipped with synthetic aperture radar and electro-optical sensors, WG-8 can collect 10 data, real-time intelligence, support anti-ship missiles such as DF-21, DN, DF-26, strengthen China's anti-access strategy in the South China Sea and Taiwan Strait. 2023 leaked documents show WG-8 deployed at Liaoan Base, aims at Taiwan, and U.S. bases in Japan, Korea. Compared to SR-72, WG-8 has lower speed and depends on mothership, but early deployment shows China's ambition to compete with US-Russia. Meanwhile is betting on Mike-41, also known as PAKDB, a sixth-generation supersonic interceptor developed by Mikoyan Mike-2, replace Chomike-31 Fort Howard, with expected speed exceeding Mach 4.BA, can reach Mach 5. Mach 41 is designed to operate at altitudes near space, from 12 to 45 kilometers, enough to intercept supersonic aircraft, such as SR-72 missile or even satellite. Armed with long-range missiles, advanced phased array radar, and multi-layer stealth, Mike-41 is Russia's answer to U.S. new-generation platforms like B-21 Raider or SR-72. However, unlike SR-72 and WG-8, Mike-41 is still a manned aircraft, poses major pilot safety challenges at hypersonic speeds. Russia also faces financial and technological constraints, making PIK-41 progress likely to be slower, with test flights expected by the end of the decade. Rockstar is not just an impressive fictional machine, but also a reflection of Loki's ambitions. Martin with SR-72. While the US leads with technologies like scandium ceramic composite and liquid hydrogen cooling, China and Russia are also making headway with WG-8 and Mike-41. This race is not just about speed, but also about power. Force, the foundation like SD-72, WG-8, or Mike-41 can shape the conflicts of the future. Scotland repeatedly teased, speaking about BAD printing, integrated cooling channels in materials, graphic illustration at the conference, interactive transfer around Dark Star, speed of digital transformation, heat-resistant engine, hypersonic race, US, China, Russia, China Z-10. WG-8 by flaunting immature technology, Mike-41 by ambition, but finance and pilot safety are weaknesses. US, SR-71, degree, SR-72 by pioneering to overcome technological limits. Hypersonic UAV combination, inheritance from the legendary Blackbird, now transformed into Sun SR-72. Will SR-72 become the card to change the global balance of power, or will the hypersonic races themselves ignite for a new era conflict? If you find this video valuable, useful, don't forget to like, subscribe to the channel, and share your thoughts below. I'm Hi. See you in the next video.